Algebra 2, guys, hope you're doing good. Hope you're watching these videos. And if you are watching these videos, then you're all good. I guess I don't need to be so severe. But hey, these videos are your notes. These videos are your lectures. This is like, hey, you show up to class. This is what you're going to see. So put in the time and you will be fine. All right. You don't put in the time, maybe not. All right. Okay. Before we jump into the math part, listen, I just want to make sure you guys know, I know this is different, but I love you guys. I'm praying for you guys every single day. All right. So if motivation is difficult for you, let me know. Okay. And maybe there's something that can be done. Maybe there's not. And it just might be a matter of like, hey, we just need to acknowledge that motivation is hard right now, but that we can push ourselves. Okay. We can do this. There is a goal to this. Every single section has its own little miniature goal. All right. Do the best you can. Do well. We don't do well. We ask questions. We get better. And we will eventually be doing well on the test. Okay. So there we go. All right. Let's jump into it. We are officially at the last section of your first chapter for Algebra 2. All right. We're looking at parent functions. Go to page 67 in the textbook. This should be quick. We got one key term, but you do have a very important chart to copy on page 67. Okay. So the parent function chart is super important. Copy it down. This was going to be vital on your test. And this is going to come up again and again in Algebra 2. So you really want to put in the time now to best understand what this chart is even telling us. Okay. Another little note right down there. If you do have your TI-83 already purchased or your TI-84, this is going to start to come in handy. You can totally be done without it, but it's just important that you guys, if you get it now, get it soon. And that way you have time to best understand how to use it and all these cool tricks that I will be teaching you throughout the course. Okay, so if you don't have your TI-83 or 84, let's get that soon. That way you are able to use it in chapter 2 and so forth. Okay, here we go. There's that. Let's jump right into example problems. Okay. That parent function chart, we're going to be looking at that. By the way, PF, you'll see that right there. PF, that is that is parent function. That's what PF means for me. All right, PF, parent function. There we go. All right, so 1A, we're doing all these example problems. I'm on page 67. Scratch that, I'm on page 68. That's where our 1A starts. So G of X equals x cubed plus 2. The first thing you want to do is determine what is the parent function. In other words, what is the original plain basic parent function look like? And I already gave it to you right there. So the book doesn't. You would need to determine this. So PF for this one is just x cubed, or x to the third power. And what does that look like? There's your graph right there next to it. Okay, so let's just make sure you're tracking with me here. This is the graph for the parent function of x to the third power. All right. And the directions, step 1, say, okay, what is the name of this parent function? And the name of this parent function, it is a cubic. Okay. So that's part 1 of the answer. It's a cubic function. Part 2 says then describe the transformation. So what are we doing here? Remember in the last section, section 8, we did a lot more with, okay, what's the translation or reflection, whatever we're doing with it. We might be a stretch or a compress, all that. So this is a cubic and we're moving it, all right? It says plus 2. So what does that mean we are doing? We are going up 2. Okay, so that would be the next thing that we need to say is this is up 2. I'm good with that. Okay, you don't need to go in any more detail. That's plenty description for me. Okay, let's take a look at 1B. All right, so for 1B, the equation given, we have G of X equals, in parentheses, a negative X then to the power of 2, or squared. Okay? So step 1, we got to figure out what's the parent function. Okay, the parent function is going to be the just generic x squared. And what does it look like? The parent function looks like that. All right? That's a parabola. That's a parabola that opens up. It's a positive parabola. It makes that smiley face. So you guys, if you remember it all back in Algebra 1, if it smiles, you're happy. Maybe you're a little positive. Parabola, smile, positive. If it upside down, if it's a frown, that would be a negative parabola. Okay? So then once you know what the parent function is, go ahead and look at that chart. What is the name of that parent function? This is a quadratic parent function. That's the name of this one. Then we need to figure out what is going on with this, all right? I don't see a plus something or a minus something. I also don't see anything clearly being defined as like multiply it by something, but we got that negative sign out there, okay? And if you have a negative in front of x, then that means there's a reflection going on, okay? That's an important note to make. If you have a negative in front of x, there is a reflection. Now, what kind of reflection? That's going to be a reflection over the y-axis. So let's write reflect over y. All right, a reflection over the y-axis if there's a negative sign with the x. So what does that mean? What if we had a negative sign with the y value, or that g of x value? Then that would mean it's a reflection over the x-axis, okay? So that is what tells us what's happening to the parent function. There's a negative sign. That's the only thing out of place here. What does that mean? Reflect it over the y-axis. All right, last example problem, guys. Let's jump into it. Then we will be done. They give us a whole series of points that we have to graph here. Okay, so let's do that real quick. Let's graph these points. Okay, so we have a -4 and a -12. That's going to be all the way down here. Okay, so a -4 and a -12. Then we have a -2, -6. So -2, we go 1, 2, 3, 4, 5, 6, about halfway down. Okay, the next one I believe is 0, 0. And then we just go opposites. We got 2, 6, 4, 12. Okay, so let's see. 1, 2, 3, 4, 5, 6. Okay. And the last one here, we have 4 12s. That's going to be all the way up top. Okay, so let's take a look. Ultimately, what is this graph? It really looks like it's going to be a straight line. If we connect all those dots, that is going to be a straight line. Now, I realize I can't perfectly fit this here. And of course, drawing that straight line is going to be the best job Mr. A can produce for you. Let's see if we can, there we go. Let's connect it all the way through. So what is a straight line? When you go back at that chart, what type of, right there, PF question mark, what parent function are we doing? No, use that parent function chart. It's going to help you. It's going to get you the answer really, really quick. That's a linear. It's a linear parent function. And now we need to take a look at that graph. If the original parent function is just x by itself, clearly we are not fully making just the original. We're doing something to it, okay? If we had a true parent function that was linear, every x value would also equal the y value. That's an important note to make. Meaning if x is 1, y is 1. If x is 2, y is 2. Okay, but that's not what we're seeing here. I see x's and y's that are clearly different, and I need to figure out how do I get, for example, to 12. How do I get to 12 if my x was 4? Okay, So that must mean that I am doing something to x to get to the y. And what am I doing? Multiplying by 3. 4 times 3, that's 12. 2 times 3, that's 6. 0 times 3, well, that's still 0. Negative 2 times 3, that is negative 6. So this is really what the equation looks like. So I took the parent function y equals x, and I did something to it. I multiplied by 3. Now look back in the last section. What happens if you multiply something in front of x? You are stretching the original parent function. And we're going to call this, change the color here. This is a vertical stretch by a factor of 3. That's what VS is going to mean here. Vertical stretch. Okay? So your answer is that this is linear. The parent function y equals 0. And what did we do to it? A vertical stretch by a factor of 3. Okay? That's it. That's what we got, guys. All right. Miss you guys. All right? Stay confident. Stay positive. Keep working hard. And you guys are going to be just fine. All right. See you in the next one.